When you go on the internet and look up suboxone, there's many definitions for suboxone. So let's review what suboxone is.
Communication between two neurons begins when an electrical impulse called an action potential travels along the axon of a presynaptic neuron toward the axon terminal. The action potential cannot cross the synaptic space. When it reaches the axon terminal, it causes membranous sacs called vesicles to move toward the membrane of the axon terminal. The membrane of the vesicle fuses with the membrane of the axon terminal, enabling the vesicle to release its contents into the synaptic space. The molecules released from the vesicles are chemicals called neurotransmitters. They drift across the synaptic space and bind to special proteins called receptors on the postsynaptic neuron.
Suboxone acts as an antagonist that blocks other opioids. Suboxone produces sufficient agonist effect to enable opioid-addicted individuals to discontinue the misuse of opioids without experiencing withdrawal symptoms. As a medication-assisted treatment, suboxone suppresses withdrawal symptoms and cravings for opioids. It does not cause euphoria in the opioid-dependent patient, and it blocks the effects of the other problem opioids for at least 24 hours. Suboxone is in a category of its own. There is no other drug compound like suboxone. As a basic explanation adequate for our purposes here, suboxone occupies the same receptors in the brain as that of more traditional opiates like heroin, methadone, oxycodone, etc. However, the claim is that it doesn't produce the high associated with these other substances. Therefore, a person formerly addicted to opiates can theoretically live a productive life while on suboxone, functioning in society and all the while avoiding withdrawal symptoms. So how does suboxone work? When the opioids attach themselves